Hi, I'm Peter. I work for Kernel Labs, and I'd like to talk about the work we've done recently to make it easy to port OKL4 kernel to a new board. While it's never going to be as easy as taking some hay and giving it to one of these guys, yeah, it can be easier than it has been. If you look at our current public release 2.1.1, you'll see the first stage of work we did for that, with the board code now sitting under the platform directory. This is the version that Benno gave his talk about at LCA in 2008. You can see that video here. Yeah, if you look at that, you will get quite a good overview of the issues involved in porting the OKL4 kernel to a new board. You'll also hear the term SoC. That stands for Silicon on Chip, and it's the term we've settled on to refer to the code which is specific to a new board. And while an SoC is not the full board, it provides enough of the specification that with that you should be able to easily get the OKL4 kernel coded and running on the new board. What we've done since then is we've properly separated out the core kernel code and the SoC code and provided, in terms of functionality, and provided a nice clean interface between the two, which in one direction specifies what the SoC code is to provide to the kernel, core kernel, and on the other hand, what functionality the core kernel provides for the SoC coder to make their job doable. That gets rid of the case where the SoC coder was faced with pretty much the complete internals of the core kernel, which made it way too easy for the SoC code to touch something it really shouldn't touch and cause the whole kernel to come crashing down in obscure and really hard to debug ways. So now, once the kernel actually supports a given CPU, all you need to care about as an SoC coder is providing a system entry point and ensuring the system state is correct, providing the core kernel with the addresses of the I/O areas it needs to map in. You need to route interrupts, but that's after the core kernel's pretty much told you what you need to do with them. You need to handle the console I/O if the console's enabled. You need to provide reboot and panic functionality, and if there's any extra timers specific to the SoC chip, you need to handle those. And that's really it. Then you can compile your SoC module. You can either compile it as part of the normal kernel build, or you can compile it separately and then link it against a kernel which either you built or someone else built earlier. And because the final linking is handled by Elfweaver, it will do version checking on both the module and the kernel to make sure that they're both talking the same API, which is a way into talking about Elfweaver. Elfweaver is our system linking tool which puts the whole final image together. Malcolm's done a separate video about that, and I recommend you go and look at that to get an idea of what extra configuration information you'll need to provide to get your new SoC module and kernel full linking and running on your new board. Yeah, that's not too hard, is it? No, it isn't. See? And while it may not be as easy as just eating hay, it's getting much closer. And the one last thing I'd say is to stew it. You can actually tend your alpacas and stay in the tech industry, like this. Bye!